Okay, so here we have the joystick wired up to the Arduino, but we're also going to connect this NeoPixels grid together. And both of these things need 5 volts to work, and we don't have two 5-volt connections on the Arduino. So how we solve that is we're going to use what's called a breadboard. So the breadboard is this thing here, and the breadboard is just a prototyping platform that is easy to connect to with these jumping wires. So how a breadboard works is, in this configuration here, that the columns right here are all connected together, but the rows aren't. So what I can do here is that I can connect wires together and make sure that they actually are the same thing. So if I just take two random wires here and I connect them together and I put them here in the same column configurations, then these two pins will actually be connected together through the board here. But they will not if I place them next to each other, like so. So here they're next to each other, and that means that they are not connected. Then here in the middle, there is also a small gap. And this gap is because that there is also no signals going through from one side to the other here. So if I connect them, even though I put them in the same row, in the same column here, they're not connected because they are opposite side of this gap. And then we have what's called the power rails up here. And the power rails are, of course, for power usually. But they're connected the opposite direction. So they're connected in this configuration where they are in the same row, they are connected. But again, here in the middle, it's they're not connected through. That differs a little bit from breadboard to breadboard, but this one doesn't have a connection through the middle here. So if I want to have multiple things connected to my power, I can take two jumper cables like these two and connect them all the way here in the end, and then input that into the 5-volt and ground connection for my Arduino. So I'm going to pull out the two connectors for the joystick, and I'm going to input 5 volts and ground here. Then I'm going to take these two connectors, of course, checking which ones are the ground and which one is 5 volts. So for me, yellow is 5 volts here. So I'm going to put them in like this, into this connection here. Okay, and I'm just going to leave the two analog inputs over there. So now it's time to wire up the NeoPixels together with the breadboard. And the NeoPixel has these 3 wires, where 2 of them are the power and 1 being the signal. And so I'm going to take the 2 power connections here, the gray being ground and for me blue being the positive. I'm going to connect those 2 into the power rail into the breadboard. And I can't really reach over to where the Arduino is over here. So I'm just going to connect that into the breadboard right here. And I'm going to take another jumper wire. I'm going to connect those 2 together in the same column here. And then I'm going to connect this wire into number 3. So by wiring these 2 together, it now goes through the breadboard and signals over to the Arduino. So this is just a really handy way to use the breadboard. And I actually already have uploaded the code for this to work. So let's see what's going to happen here. Uploading, just to make sure that I am on the newest version. So what's going to happen here is I have to orientate this correctly. That when I push it, so this is just about mapping. So I see this being left and right, and this opposite being up and down. I think I swapped X and Y here, so I'm just going to flip those 2 around. I can do this either in code or manually. I'm just going to flip them around. It's going to give me the same results, but it's going to give me a little bit different mapping functionalities. So now it works. You see up, down, left, right. So I can control this red dot around over here on the matrix. So how do we do this? Let's take a look into the code. So this code is a bit more complicated than just so. I stole most of this code, and I'm going to tell you how I did that. So under examples down here, there is the fast LED, and under that there is an XY matrix. And inside this is basically what we have. We have an XY matrix. So I went through this code and I looked for everything that I needed as important. And I'm just going to tell you what I took. So I took the fast LED library, of course, that's over here. The LED pinout. And that's basically it, actually. The most important functions that I found are these three lines here. So these width and height of the matrix, and I've of course changed that to a 5 by 5 for my case. And then this one is rather important because it tells a little bit about how the different things are connected. So, and our ones are connected in this configuration right here. So this value just has to be true. If you have a grid that is connected like this instead, you have to put this to false. And then I went a little bit further down and I found this one here being an XY command line. So this is just this is like a small library inside your code. It's what we call a function. And I have that function right here. And I don't use it for anything. I just copy and pasted it. It's nothing really to it. And then I went further down and everything else is very similar to how it is in the Blink sketch. So this comes from the Blink example, and this does from my other videos as well with the Fast LED 102, I think, where I talked about this master brightness control. So that's all the code that I needed from here. Okay, so here I have the two pin modes again, and we already talked about all this, but what is now different is these different parts here. So the first thing I do in the loop, every time I start the loop, I clear the whole matrix and I show that it has been cleared. So this will cause a little bit of a blinking. But it makes sure that I refresh the page every time. So the next thing I do here is called what I call smoothing, and that's these lines here. We already talked about for loops in the NeoPixel. And what I do here is just that I say from 0 to 10 increment by 1. So I run through this code 10 times and I read the values x position. So I take the previous value and add the new value. So what this effectively does is just adding 10 times what the analog read here. And the same I do for the y position. And right when I exit this, I divide them by 10. So this gives me the average by doing this. And it gives a little bit of a smooth experience. So that's like smoothing, we do like that. And then this is the same. The mapped function is exactly the same. I just take this smooth function and input it into here. And then I take this LEDs, and this should look fairly like we usually have them. Usually it looks like this one, that we have LEDs, and then you can input like a value from 0 to the number of LEDs that you have. So usually we tell it like 0, 1, 2, 3, 4, 5. But because we have imported this function up here, this XY function, I can write LEDs and then XY parentheses and then tell it an XY position. So my XY position is going to be the mapped position from X and the Y position in here. And I'm going to make that to the red color, and then I'm going to show it. And then it's going to go up to the top again, up here, clear it, and show it. Let's just take a look at what happens if I don't do these two lines and upload that code. So everything looks pretty similar now, but what happens when I move this is that I actually am tracing where I move. So I can't really see where I'm at right now. I'm just jumbling around until I get every single one of them to complete. So it doesn't clear right now. Right now it's in the middle because I let go of it. So I know it's in here, but everyone is lit up. So that's why I do this clear command, because if I clear it, every time that it's watching over it, I can control this dot here around. Okay, so that's how we do sensor inputs and this human interface to the NeoPixels. In the next video, we're going to make this into a game where it's going to randomly place an LED color on one of the LEDs here, and the goal is then to catch it. So the goal is to go over and catch where the LED is going to be lit up.